Okay, good morning. Today we're going to talk about NanoPaint, my project submission for the Nano build-off. Now, I posted about this on Reddit yesterday, and I got just such incredible feedback. You guys really are awesome, and we got the start of a really neat collaborative drawing. So, this community is just something else. But anyways, I couldn't stay up all night to answer every question. At some point, I had to go to sleep. So I thought maybe I would just make a little video now that it's morning to explain everything. So, I literally rolled out of bed like 10 minutes ago. But anyways, what we're going to do here is talk about NanoPaint, how it works, and importantly, we'll answer some of your questions by going under the hood and showing the math, okay, as well as the code. So, as I said, this thing will be open source, although if you want to get an early crack at looking at it, just use curl on my web pages. I intentionally did not obfuscate my code, so you can go look at it. I'll open source it like probably later today or the next day. Maybe you want to clean a few things up, but if you want to get started just looking at it, feel free to do that. But yeah, so without further ado, we'll talk about NanoPaint and the underlying implications for this when it comes to Nano as a platform. All right, so this is NanoPaint. This web browser right here. It's a web page wherein we work together on a collaborative drawing. It's inspired by Reddit's r/place. Okay, so for those of you who participated in Reddit's r/place, you know what I'm talking about. But for those who didn't, like me, by the way, I only joined Reddit like 3 months ago. The way it worked is it was this big grid, and everyone was able to like change pixels every now and then on that grid, and the result was this emerging like community chalkboard, so to speak. But NanoPaint's basically the same thing, except it's got a nano spin on it. And the reason I did it is because it demonstrates a mathematical principle, which I think has some pretty great implications for Nano itself. But before we do that, let's just explore NanoPaint itself. So, you open this web page up and you see this thing, and it tells you to click a tile, choose a color, and scan the QR code. All right, so the user goes and they look at it, and they want to click a tile. Well, suddenly the screen goes to full, and you suddenly see the wonderful stuff you guys are making. So NanoPaint's basically this big grid. You can drag it around, you can zoom in and zoom out. Oh, that's funny. It's kind of choppy because, since I'm recording, it causes the frames to lag a little bit. But anyways, you zoom in, you zoom out, and if you do this at home, you'll find it's pretty trippy because right now the starting pattern is a bunch of like rainbow dots, and the consequence of this is that there's all these like symmetries inside. All right, anyways, that's a total tangent. Basically, you can zoom and pan on this grid and look at the stuff people have made, maybe get inspired. Like, look at this pizza slice. This is just such a wonderful thing. I really like it. It makes me very happy. I thought it was creative how, like, the background colors this, like, gray, and the outline for the actual pepperoni pieces is, the same as the background. So I thought that was a pretty creative use. I think someone over here started making this little stick man. I wonder what he's going to say soon. We've got a smiley face. We've got the Nano logo. I'm so glad someone got that in there. We've got a little orange. We've got a turn up, I think is what that is. I think this is like a drop in a video game or something. Someone says hi. There were some other things too. Someone likes the number 47. We've got Pac-Man. That was really funny. I like this. This is cute. Then we've also got fast, because NanoPaint shows how fast Nano is. Or, okay, I didn't draw it. I don't know why you wrote fast. But, yeah, so we're going to do a little tour of the program itself. So you look at this. You see what everyone's doing, and you're like, wow, that's so cool. I want to, do something. Well, here's how you can do it. Like, let's say you want to draw something. The way it works is you go and you pick a tile, and then you just click on it. Okay? You're suddenly presented with a color picker and this QR code. It said to pick a color and then scan the code. All right, well, my favorite color is personally orange, so maybe I want to do like an orange. All right, so I might change the color and, oh, whoa, do you see this? Look at that. The QR code changed in response to the color I'm picking. Interesting. Okay, well, let's just pick our color, and, then we'll worry about the QR code. So I pick my color. This isn't quite my favorite shade of orange, but this is one of them. And then I go, okay, I'm satisfied. Here's the QR code. All right, now I'm getting my phone to open Natrium so that I can actually scan it. So you can't see this because I'm recording my screen, but basically what comes up is a transaction that I can send if I just hit confirm. Right now it says it costs like 0.001 nano with a little tilde at the end. Okay, the tilde meaning that there's some lower order digits that are all non-zero. We'll get to why that is soon. But okay, so I have this thing, and you're just gonna have to trust that I hit confirm when I say I do. All right, so I hit confirm now. Oh, Face ID. Okay, so notice this: the QR code and other thing went away, and this thing slowly transitioned to the color that we wanted. Oh, cool. So we've got that. Oh, what if I wanted to draw another? Oh, look here. We've got a recent colors list that lets us just pick the color that we might scan it a second time. Okay, so, interesting. So I could scan this QR code, and, if this program is correct, just like we saw a second ago, we should get an orange tile there. Notice this, the QR codes are different based on the tile position as well as the color. So it changes in response to the color, and it also changes in response to the tile. Let me scan this one real quick. So it should be going now. Yeah, there we go. So you can see then that this one changes to the same shade of color, or the same orange that we saw here. All right, so that's the idea. Notice this. What have we just seen here? We've just seen that without me having to put in my Nano address, without me having to sign up for any email or anything else, the system somehow responded to the payments that I sent and fulfilled the request on the grid. If there were other people drawing right now, you would see their requests getting fulfilled, the colors slowly changing from gray to something else. And yet, none of us put in our information. How does this work? Okay, that is the real meat of my submission to the NanoPaint, to the Nano build-off. Okay, NanoPaint is an instantiation of this technology. I needed an example to express it, and NanoPaint was just the perfect candidate. Okay, so that is what we're going to explore for the rest of this video. I guess one last note. We also have some classy jazz you can listen to if you just hit that music icon. I don't want to start playing it right here, though, because I'm recording. But anyways, this is NanoPaint. So now that we see the idea, we'll go over a few things. So one, if I leave full screen here, this is what the website looks like. If you want to do it yourself, I should have said this. You can click my faucet link and it'll give you some free nano. I think that'll give you enough for like 2 or 3 spins, depending on how much is in the faucet at the time. Also, if you're on mobile, I recommend you switch to desktop, but you can also click this Natrium link. It changes in response to the, tile and color that you pick. So once you do those things, it'll actually get encoded into the link. And if you click this on mobile, it will actually prompt you with the same payment and everything. But I just think it's far more satisfying to, do it with the scanning, because that's so much more fun. And also, it's great, if you want to introduce somebody to Nano, you can, one, use the faucet to show them how fast they can receive money, and then you can use NanoPaint to show how fast you can send money. So, here we got both directions of it. One last thing. How's the money being used? Well, 20% of it goes back to the faucet. So that means it's like kind of a cycle. The rest of it, the vast majority at the very least, is going to my other work with Nano. So, I know it costs a very tiny amount, but it does cost an amount. And if you want to see more Nano type stuff from me, use my service. Okay, so, here it is here. Another feature about it, on browsers that don't support full screen, or at the very least aren't in compliance with like the spec, instead of it clicking to go full screen, it just starts out a little bigger, okay? And then you can like zoom and pan and move around from the actual like zoomed out view itself. All right, so this is what it looks like on a browser that doesn't quite meet the spec. All right, so that's enough of that. I think now we can go into the underlying tech. So I'm making a little write-up on it on my website. This URL right here will take you to the write-up. It's not done. But Basically, this is going to actually show you, like, in a more rigorous and mathematically defined way how exactly it works. I'm trying to write it in such a way that it'll be useful for people outside of Nano. Perhaps it gets some people to start using the service, and that would be wonderful. But I got to be careful how I say things. Like, I'm saying, I wrote here last night that NanoPaint's the first true second layer service of the Nano network. I probably need to back off that claim. That's a bit much. Also, on Reddit, you can express your emotion with, like, emojis and stuff, but the problem with this kind of academic writing is it can be rather challenging to express it exactly as I mean it. So, okay, that's the real formal stuff that we'll talk about at a later time or something. Anyways, you can just go to that link later. I'll post about it on Reddit and get the full formal specification that I'll have done by then. But the thing I'm going to talk about today is, the stuff that you can immediately start using in your Nano programs. Okay, it's the same stuff, but just for developers. So the way it works is as follows, all right? In NanoPaint, we have payments, all right? And observe that the cost of the payment was like 0.001 nano. Notice this, right? So that's like the 27th decimal place. Well, it turns out, I'm sorry, that's the third decimal place. It turns out that nano has some super high divisibility. 1 nano is equal to 10 to the 30 raw. So what that means is the remaining 27 digits or so, or I guess 26 digits, can be whatever we want. Okay, we can encode information in them and not substantially affect the price. Okay, that is the idea. The payment network itself can transfer not just money, but intent. So a second layer service can sit on the side of the Nano network, just reading the decentralized data stream and respond in the real world to things implied by the payments there. Okay, so here's an example, okay? In NanoPaint, we want our payment to include information about the X and Y position of the tile, as well as the red, green, and blue values of the color, okay? So we've got an X and a Y, and an R and a G and a B. How can we encode it into the payment? Well, I'll go into the formal math of like how you can build your own in the paper, but I think if you look at this example, it'll make sense. All right, so the idea is this. We create a convolution, all right? That is, we're going to have a function that takes the values to an encoding, and then another one that takes an encoding to the values. All right, so for example, here's the encoding we actually use, all right? We have the X position plus the number of tiles wide times the Y position plus that times 256 times red plus that times 256 squared times green, then that times 256 cubed times blue. Okay, so that's what we do. Why do we do it? Well, here's why. Notice this, because the board is wider than it is tall, no matter what X value I have, even at its biggest, the smallest Y value, when multiplied by the width, will be a number that exceeds the X value. Okay, so think about it, right? No matter what the X value is and no matter what the Y value is, if I add them together in this way, where I shift this over by tiles wide, then the number that's created encodes X and Y. Okay? How could I get them? Well, I know that the lower order information is the X, and then if I remove the X from that, and I'll show you how to do that, the remainder has to tell us the Y value. The same thinking works for the colors. So for the red channel, if I multiply by tiles wide times 256, then there's no possible way STY will overlap with the number that you see here. I guess actually I could have just multiplied by the tiles tall, and that would have done it too. But 256 happens to be bigger. Okay, that's funny. That comes from earlier sizing. Okay, so, I'll write about this in a little bit, but I probably should have said tiles tall here. But, okay, that's something I'll think about later. The idea, though, is this, okay? The biggest thing you have here, shift this over such that when you add them together, you don't have any issues, okay? Then the biggest thing for here, take this and shift it over by that and add it to the cumulative sum that you've already gotten. Then the biggest thing this could possibly be, shift it over. So in this case, 256 actually makes sense. Okay, so the biggest thing this could be is 255. So if I multiply by 256, there's no possible way the resulting number here exceeds the number that you see here. I'm sorry, there's no possible way the resulting number you see here somehow overlaps with the number you see here. Okay, and then the last one, you just shift over by the biggest thing this could possibly be, which is 256. So, sorry that's slightly confusing. This should probably be tiles tall. But anyways, the idea is as follows, okay? You encode the information in such a way that you get this special number, which is the amount you end up paying, okay? Or at least, gets to the amount you end up paying. I add a little bit because I want to make a tiny amount of money, right? But the encoded value that you put in the rightmost digits, you shift each of the component parts over such that the sum, when you put them all together, ends up specifying exactly one encoding, one in which you are able to pull out the information in the following manner. Okay, so here, we actually pull the encoding out, that is. All right, so you take your encoding, okay, in this case, we'll just call it the encoded value, and as before, when you did all your shifting, we had to multiply by a bunch of things. Well, in this case, we do moduli. All right, so for x, since it was the smallest one, you take the encoding and you take the mod tiles wide. Okay, so notice that. By the way we've encoded it, there's no possible way that this number will somehow capture y, r, g, or b. Why? Because we multiplied by numbers such that we shifted the whole thing over, and only x is exposed in the lowest order values. Okay, so you take the encoded mod tiles wide, and then you modify the encoding to get rid of the x information. Okay, so here I'm saying remove x from the encoding and then divide by tiles wide. What does that do? Well, when I remove x, then I now have a number who encodes the remaining the remaining information. And then by dividing by tiles wide, I remove the multiplication I did on each of these. Okay, what does that do? That creates a new encoding that has y, r, g, and b. How do I get y? Well, I take the encoding mod the size of y. Okay, well, as I talked about before, I had 256, but it probably should be tiles tall. Not probably. I mean, it should be tiles tall. But anyways, so we have y, and we pull its portion of the encoding out. There's no possible way r, g, or b overlap with y here. So there's no possible way r, g, and b overlap with y because they've been shifted over by successive multiplications of 256. Okay, so then you modify the encoding. You take the encoding, subtract out the y such that we don't have the y information anymore, and then you divide by the size of the y space, okay? So, you divide by tiles tall. All right, then the remaining is exactly much the same. Now we have a thing that only encodes r, g, and b. So you take out the r, use it for the value of r, and then alter the encoding such that you only have now an encoding for g and b. And you just keep repeating this, okay? So, maybe you've got a video game, there's characters, there's email addresses, there's something. I don't care what it is. You just multiply everything together in this convolution, and then you start removing the entries of the component parts. All right, and once you have the information, well, you can actually react to it. So in my case, we change a tile. Okay, so that's the way this works in terms of an encoding. I think that's a good enough example that you'll actually be able to use it. My apologies for the 256. I totally forgot about this, but I changed the tiles wide and tiles tall. It used to be a square, and so this is kind of the result of that. But I need to... It's not really bad because since tiles tall is less than 256, it's not possible that this encoding scheme gets screwed up. But you get the idea here. If you've got a bunch of information, you can create a convolution. All right, so that's the idea. A few other things about the program, as I talked about on Reddit. It is open source, like I said, so you can benefit from this. I really hope you do. Like, please go create some wonderful things. I think this community has such potential. Not that there aren't already great things in it, but I'm saying we can do so much more with techniques. And this is one such technique. Okay, so that's the program here. You can go look at it on my website. Okay, so in addition to it being open source, it's also asynchronous. So this is kind of cool. There's not even a drawing loop for just painting the canvas. Okay, there's no like sleep 60 milliseconds and then repaint the board. It is 100% asynchronous. Nano lets us do some really cool stuff. So like, here we're actually, when we pan and zoom and stuff, what's going on is transformations are being applied to the actual canvas element itself. And then furthermore, because the network itself encodes all of the state, the server can pretty much be just totally asynchronous as well. I mean, it's able to just listen to the network, and then the moment it receives an event that comes in from the Nano node, it will respond to it, and then everybody who's connected by sockets then gets informed of the update, and then bam, suddenly you find yourself with a changed grid. So that's another aspect. Oh, whoa, that's new. I didn't see this. Okay, anyway, sorry. So the that's awesome. Okay, that threw me off for a second. So anyways, so the thing is asynchronous. It's also totally vanilla JavaScript, so there's no like crazy framework here that binds us to a specific design pattern. We really have free reign, and I hope then that means that someone will get inspired, use pieces of it. Maybe you'll make something totally different. Who knows? Maybe it'll have nothing to do with Nano. I don't know. Maybe make a video game or something. Doesn't matter to me. It's open source. Just try and help other people you can by letting them know about what you make. Okay, so I forgot to talk about Reddit. The Reddit comments were wonderful. A lot of positivity. Some people had concerns. It's okay. I guess I'll respond to them. So, I like what NATO Damon is saying, or NATO Demon. I really hope he goes and does what he says, which is to use some of the ideas and make some incredible software. This is the whole goal, okay? I really want this technique to start being used. And I think it has a lot of potential. There's some really neat applications of it. I talk about how you can maybe use it in a video game. Like, for example, maybe you have a character and he's got a username and there's a object you want to buy. Well, instead of telling your mom to go get a credit card number or something, obviously I don't advise little kids go and do this, but you know what I'm saying in general. Like, it's a hassle to go get a credit card out. You could just scan a QR code that the game presents, and the payment itself would encode the object. Furthermore, maybe your friend wants to send you something, okay? Well, one way he could do it is buy that on your behalf. He could just scan the same QR code, and then suddenly you would find your character credited with whatever object you wanted to buy. So, there's some real potential here. So you could do that. Also, we talk about how much info you can actually store. You can store quite a bit. It's deceptive, right? So around 30 digits, let's call it 25. That's 10 to the 25th. That's a lot of information, okay? These aren't bits, mind you. These are digits. And that is, that's some real wiggle room where you can play with some stuff. So, that was part of the discussion, people talking about the size of it. So, just some wonderful comments. But okay, anyways, this one guy, Throwaway XOOOX, which by the way, I think he has posted some really informative stuff on this sub. So, I appreciate his response. One thing I do want to say, he talks about not trying to hurt my feelings with this. And, crypto has a serious issue, guys. We need to make sure that we have good faith discussions because there's so much, people will allege bag holding, but basically it's people get invested in their coin and they want it to succeed. And when you put forward genuine criticism, people just freak out. So, imagine if I go and post this on r/cryptocurrency. I can already imagine the kind of comment section that would be created. But anyways, I'm not offended. I really appreciate it. And I think we need to think through these things because, all the different angles have to be considered. So Throwaway talks about is this size really big? I think it's sufficient, but it does require some creativity. So, for example, right, email addresses can be pretty long, in particular because you can have any website be the domain name, and websites can be very, very long. So you wouldn't be able to encode the information in a single transaction. You'd have to split it up over multiple. And I totally agree. Okay, from a user interface standpoint, if you go show like 20 QR codes and someone's sitting there scanning them, that's just not going to work. However, this is just a tool, and there's ways to leverage it that can get around some of the things. All right, so you got to be a little creative with it. So for example, all right, fine, we can't do an email address, but what if I assign every person who signed up for my service, I assign to each of their emails a unique ID? Okay, well, so long as the number of people signed up doesn't exceed 10 to the 25th, then you can associate that user with the payment that you want to do. So you gotta, there might be some transformations that are involved, but the idea is you really can do some pretty crazy stuff. Or let's say you wanted to place a block in a Minecraft world. Okay, well, obviously the world is too big for a single transaction, and we're not going to require somebody to just scan a million QR codes. Well, what you do is you might say, all right, instead of having you purchase the specific block location, maybe you buy points in the video game. Okay, maybe you get some points where you scan the QR code, and embedded into it through this technique is the username or the account ID or something. And then with a single transaction, the individual finds them with some points. And then maybe they spend the points on objects or placing a block at a random position that they type in chat. You see what I'm saying? Like there's definitely ways of employing this technique, but yes, you're right. It will not in general work in every circumstance, okay? So I jokingly talked about having a second layer coin. I don't think we should do that, okay? And yes, that would require far too many transactions. Now, what about info that you really, though, have to send over multiple? Well, I have the feeling that's the kind of stuff servers can do, right? I'm not actually saying a user should scan a bunch of QR codes and split up the messages, but, servers talking to each other, they might be able to do it. And what's more, servers doing that could do it in such a manner where you don't even know what's really going on. Maybe you encrypt or have some cipher or something on the payment amounts. That way other people just see transactions, but what's really going on is something deeper. Or maybe you have a long-term type thing, like over time information is sent through just a trickle of information or trickle of messages, each encoding a little piece of info. Another thing, in terms of how many digits we can safely use, 25 is sufficient. Now, let's say 1 nano becomes worth $1 quadrillion. Yeah, that could have an issue for the scheme, but honestly, I'm okay with that problem. I actually really hope that happens. But anyways, abusing the decimal, I don't think it's abusing the decimal. It's just using it. Now, he does say maybe we should extend the nano protocol. That might be a really cool idea. We could extend the protocol to have additional information. Maybe there's a 32 or 64-bit number at the end. I'm sorry, not number, number of digits at the end or something. Digits worth, you get my point. You have some extra padding that you can put at the end of your message, and that just gets sent with the payment. Only issue with that, I've read the Nano white paper, but I don't remember exactly how large the packet size is. I don't know if it's even said in there, but I know that the overall transaction fits within a UDP packet, okay? And what that means is there might not be that many bits that we can work with. But if there are leftover bits, I hope the developers will add that, because I actually agree. I think that would be fantastic, okay? Not some decentralized scripting languages or smart contract system, but just, maybe we have a little metadata and the packets can have just a tiny little bit of info for us. Or maybe you could split it over the payment and this metadata if the metadata can't be that big. Like maybe the developers can only give us a byte. Well, hey, that's a byte extra of specificity, and this stuff's multiplicative, right? Every additional bit that you get multiplies by 2 the number of things you can encode, or the size of the thing you can encode in a single transaction. So, yeah, I do agree with that. So he makes some great points. I disagree. I hope I've been persuasive in this, but you get my idea. Someone else asked for... Oh, yeah, somebody else actually is the reason the video started. He asked if I could explain it in layman's terms, and I think I have. Okay, so... Really cool stuff. You guys are awesome. This comment section is just absolutely fantastic. Someone says it doesn't work for Windows 7. I have tested all my computers, but man, I don't know where I can find a Windows 7 computer. But I'm working on it. I think my dad has one, so next time I see him, I'll see if I can get on NanoPaint with his laptop and check it out. But anyways, if you have any other questions or concerns or thoughts, definitely write about it. I also look forward to the stuff we're going to come out with this build off. I get the feeling this is just the start. Some really great stuff could come out in these next couple of days. So I guess that's it for this video. I appreciate you guys listening through my long single take, I guess. I mean, I am cutting the video up, obviously, just my long-winded conversation about it. I'll do more with Nano in the future, too, of course, right? And maybe do more videos on it on this YouTube channel. Well, anyways, thanks, guys. See you guys later.